everyone, so this is the second video for chapter 10. It's going over the chapter 10 multiple choice problems for the problem set. As a reminder, these are the formulas that we'll be using. They're included on the PDF for these solutions, and they're straight from the textbook. Like literally took a screenshot so that we didn't have to flip back and forth, just to hopefully make going back and studying or referencing something a little bit easier for y'all. So first question says, which of the following specifications could not be employed for estimating a short-run production function? And our answer is D. Neither of these will work. This is what short-run production functions should look like. And this is straight from the slides. So I'm just going to put slides down here so that you know it's nothing else. Which of the following represents a short-run cubic production function? This is also straight from the slides, and it is C. With the cubic production function of the form given, in order for average and marginal product functions to have their usual theoretical properties, it must be the case that A is less than 0 and B is greater than 0. This is also in the slides. Those determine the way the shape moves and the way that the derivatives of those curves, which give you your average and marginal product functions, the way that they're shaped as well. When estimating a short-run production function of the form Q equals AL to the third plus BL to the second, it is necessary to specify in the computer routine that the intercept term is forced equal to 0. There is no intercept in this equation, so you have to tell the computer that you don't want there to be an intercept. You want it to go through the origin. A and B are going to be the result of your estimation. We don't have to tell the computer that. If it doesn't give us that, something went wrong. And those A's and B's are over here. It's the same thing. But it's the result of your estimation. You're not making it do that. Next one says an average variable cost function is estimated by average variable cost equals 96 minus 2q plus 0.05q squared, which means we're going to have A equals 96, B equals -2, and C equals 0.05. Which of the following cost functions is associated with this estimate? So rather than working through our answer choices, we're just going to solve for both of them. Short-run marginal cost is A plus 2BQ plus 3CQ squared, which is going to be 96 plus 2 times -2 plus, Q plus 3.05 Q squared, which gives us a short-run marginal cost of 96 minus 4Q plus 0.15 Q squared. And same idea for our total variable cost. Our total variable cost is average variable cost times Q. So we're going to have 96 minus 2Q plus 0.05 Q squared times Q. I realize that there's a formula, or you can just change your exponents. It's the same thing. As with the free response questions, do whichever way makes it more sense to you. As long as you know what you're doing, it doesn't necessarily matter which way you're going. So 96Q minus 2Q squared plus 0.05 Q to the third, which means that this one works and this one works. So our answer is E, both B and D. Next one says a short run production function was estimated as Q equals negative 0.002 L to the third plus 0.16 L squared. At what level of labor usage does the maximum average product occur? So this is really asking, when does diminishing returns start? So we're going to find our average product curve, which is Q divided by L, which is going to give us negative 0.002 L squared plus 0.16 L. And then we're going to use negative B over 2A, which is 0.16 divided by 2 times 0.002 equals 40. So our answer is C. What is total product when average product is at its maximum? We just solved that this occurs when L equals 40. So we are going to take our average product curve that we found on the last slide, which was negative 0.002 L squared plus 0.16 L. And I'm just showing you exactly what we did to get this. We did that, we get negative B over 2A, which was 0.16 over 2 times 0.002, which gave us 40. We're going to substitute that 40 into our production function. So Q equals negative 0.002, 40 to the third, plus 0.16, 40 squared, gives us 128, which is D. Short run production function is estimated as same thing as last time. At 20 units of labor, what is average product? So our average product curve is defined as Q divided by L, which is negative 0.002 L to the third plus 0.16 L squared divided by L, and since there's an L in both of them, we can reduce those exponents. We get negative 0.002 L squared plus 0.16 L. And we're going to substitute in 20. So our average product at 20 is going to be negative 0.002 times 20 squared plus 0.16 times 20, which gives us 2.4. Same production function. This time we're asked at 60 units of labor, what is the marginal product? So our marginal product from this is going to be negative 0.006 L squared plus 0.32 L. And you can either get this with the marginal product being equal to the derivative of Q with respect to L, or you can plug it into your formulas that are on the sheets. It doesn't matter which way you're going as long as you know what you're doing. And that formula was marginal product equals 3A L squared plus 2BL. Doesn't matter which way, they give you the same information. So in this, we're going to plug in 60 and for our L. So it's going to be negative 0.006 60 squared plus 0.32 times 60. So our marginal product of 60, or at 60, excuse me, is negative 2.4. The opportunity cost of capital owned by the firm should reflect the return foregone by using the capital rather than renting it to another firm. Straker Industries estimates its short-run cost using a U-shaped average variable cost curve of the function ABC equals A plus BQ plus CQ squared and obtain the following results. Total fixed cost at Straker Industries is 1,000. So first, we're just going to write our average variable cost from this, which is going to be average variable costs equals 43.4 minus 2.80Q plus 0.20Q squared, which means we have A equals 43.4, B equals negative 2.80, and C equals 0.2. The estimated short-run marginal cost function at Straker Industries is, so our short-run marginal cost is going to be A plus 2BQ plus 3CQ squared. So short-run marginal cost equals 43.4 minus 5.6 times Q plus 0.6 Q squared. This chapter is a lot of plugging things into formulas and just making sure that you're not making silly mistakes when you're typing into your calculator. At what level of output is average variable cost at its minimum point for Straker Industries. For the sake of time, I'm going to just copy this information so that we don't have to write it down again and again and again. So there's the information we already had, and we are going to use negative b over 2c to find that minimum point. So negative b is a negative 2.8 over 2 times 0.2, which is a positive 2.8 over 0.4, which gives us 7. At Straker Industries, average variable cost reaches its minimum value at. So we just said that it occurred at negative b over 2c, which gave us 7. So we're going to substitute that into our average variable cost function. So average variable cost equals 43.4 minus 2.80 times 7 plus 0.20 times 7 squared, which gives us average variable costs equal to $33.60. If Straker Industries produces 20 units of output, what is estimated average total cost? So we're going to go ahead and start with our average variable cost. Then we're going to have average variable cost at 20 units. So to find this, we're going to substitute in 20. So 43.4 minus 2.8 times 20 plus 0.20 times 20 squared, which gives us 67.4. If you go all the way back to the first part where they introduced this question, they tell us that our total fixed cost is $1,000. Which means our average fixed cost is going to be given by 1,000 divided by Q, which is 1,000 divided by 50, divided by 20, which gives us 50. Got ahead of myself. Then our average total cost at 20 units of output is equal to our average variable cost at 20 units plus our average fixed cost at 20 units, which we know that our average variable cost is 67.4, our average fixed cost is 50, so our average total cost is 117.40. If they produce 12 units of output, what is the estimated short-run marginal cost curve? Well, actually, we need the short-run marginal cost, and then we're going to plug in 12. But we already know from the last several slides that our average variable cost was 43.4 minus 2.80 Q plus 0.20 Q squared. Our total variable cost was the same thing, except we multiply by Q. So all of our Q exponents are increasing by 1. And if that made no sense to you, then just go back to the formulas, it's all right. Then from that, we can find our short-run marginal cost curve, which is going to be 43.4 minus 5.6 Q plus 0.6 Q squared. And again, you can do that by either taking the derivative of your average total variable cost with respect to Q, or you plug in your values. It's totally up to you. And then at 12, we're going to plug it in. And we're going to get 43.4 minus 5.6 times 12 plus 0.6 times 12 squared gives us 62.60. Next one is apparently still highlighted, which is okay. For the short run, cost function average variable cost equals A plus BQ plus CQ squared. The average variable cost curve is U-shaped when A is greater than 0, B is less than 0, and C is greater than 0. If C is greater than 0, it makes it look like a smiley face instead of a frowny face. And A greater than 0 keeps your intercept positive so that you're not too far below the x-axis. When estimating a cubic short-run production function, Q equals AL cubed plus BL squared using linear regression analysis, you must transform the equation into linear form by defining L3 and L2 as L cubed and L squared respectively. This is true. Suppress the intercept term to regress through the origin. This is also true. There's no intercept term. Convert the right-hand side variables to logarithms. That has nothing to do with what we're doing. So our answer is D, both A and B. A firm estimates its long-run production function to be Q equals negative 0.0075 K to the third L to the third plus 12K squared L squared. Suppose the firm employs 12 units of capital. At blank units of labor, marginal product of labor begins to diminish. So 12 units of capital, this means that K is equal to 12. So before we do anything else, we need to plug in 12 for our K. So our equation that we're starting with is Q equals negative 0.0075 K to the third L to the third plus 12K squared L squared. We're going to substitute in that 12, so negative 0.0075 12 to the third L to the third plus 12 times 12 squared L squared, which is going to give us negative 12.96 L to the third plus 1728 L squared. And all we did there was type that into the calculator. And then it wants to know our marginal product of labor. So we need our marginal product curve, which again, you can either use your formulas or you can use a derivative. It's totally up to you. but our marginal product curve is going to be negative 38.88 L squared plus 3,456 L. And then we're going to use negative B over 2A, which is going to be 3,456. It's negative because it's a negative B, over 2 times 38.88. That's a negative because it's a negative in the equation. And those two negatives will cancel, which gives us 44.44. Next one says, suppose the firm employs 12 units of capital. Average product when 10 units of labor are employed is... So we already know that when we substitute 12 in, we are going to get negative 12.96 L to the third plus 1728 L squared. That's from the previous slide. So then we're going to substitute in 10 for our L. So negative 12.96 times 10 to the third plus 1728 times 10 squared. It's going to give us 159,840. Our average product of labor is defined as Q divided by L. So 159,840 divided by 10 is 15,984. Or D. '23 says the manager of Green Enterprises recently estimated its average variable cost function to be, they face the total fixed costs of $300,000. At Green Enterprises, average variable cost reaches its minimum value at, so we need our equation. It's already given to us, so 88 minus 0.026 Q plus 0.00003 Q squared. And it's going to be negative B over 2C using the formulas that you were given. So 0.026 over 2 times 0.00003 gives us 4,333. .33. And before I forget, I realized this should have a negative, and both of those negatives turn into a positive. I did it in my head and did not actually write it down. Then we need to take this, and we need to substitute it back in to our average variable cost curve. So our average variable cost, if we plug that in, is going to be 88 minus 0.026 plus 0.00003 times 4,300 is going to give us 31.67. Again, there's a lot of plugging in and making sure that you type the right number of zeros and all of your stuff in correctly. 24 asks what is the estimated short run marginal cost if we're producing 6,000 units of output. We have the same equation, so our average variable cost curve is given by 88 minus 0.026 Q plus 0.000003 Q squared. So our total variable cost, we're just going to multiply our average variable cost by Q, or plug in with your equations. It's up to you. So our short run marginal cost will be given by 88 minus 0.052 Q plus 0.000009 Q squared. So then we're going to plug in 6,000. So it's going to be 88 minus 0.052 times 6,000 plus 0.000009 6,000 squared, which gives us 100. So when Green's output is 2,000 units, average variable cost is. So we're going to plug in 2,000 into our average variable cost curve. Which apparently I did not already do the math, so give me just 1 second to get a calculator, sorry. We're going to have 88 minus 0.026 times 2,000. Plus 0.00003 times 2,000 squared. And we type that into our calculator and we get 36. I try to have the calculator math already written out, but I messed up on that. Then we know that our average variable cost at our min was 48, and that was 2,000. So we know that it's falling because it's less than the minimum. And then our short run marginal cost is 88 minus 0.052 Q plus 0.00009 Q squared. And we're going to plug in 2,000 units for that, and we're going to get short run marginal cost equals 20. So we know that 36 is greater than 20, so our average variable cost is greater than our short run marginal cost, which is true. So it's both B and C. 26 says a short-run marginal cost curve is estimated as 96 minus 4q plus 0.15q squared. Which of the following cost functions is associated with this estimated short-run marginal cost equation? So our short-run marginal cost curve is 96 minus 4q plus 0.15q squared. Total variable cost is 96q minus 2q squared plus 0.05 q to the third. Again, we're just using those formulas and substituting in. And then our average variable cost is 96 minus 2q plus 0.05 q squared. We're getting that A equals 96, B equals -4, C equals 0.15. And then we're substituting it in. But with that, we get the A and D work. And this is the question we just did. So that is the end. If you have questions, please reach out, email me, and I will help in any way that I can. I hope you all have a wonderful week.